So algebra equations is made up of two expressions and has an equals sign in the middle. So an expression has letters, numbers, and operations. So n plus 6 is an expression. We've worked with these. We can substitute values in for n and then get a value for this. An equation is where you have an expression like n plus 6 and it equals something. 12, let's say in this case. And in this case, we don't know n. N is unknown. It's our variable. And the purpose of equations for us is to solve them. And solving an equation means to find the value of n. So to find the value of the variable, there must only be one variable for us to solve it. If there's two variables, two letters, that means that for us we cannot figure out how to find the answer. You have to show all the steps as I do, especially the opposite operation, and I'll explain that next. You must line up your equal signs vertically. Most of the work that we do, there's room to line up your equal signs one above the other as you go down. What I don't want is to line up equal signs, do some work, put more equal signs and more equal signs. I want it lined up vertically. We're going to organize our equations by types. Types 1, 2, 3, 4. It basically has to do with how many steps you need to solve it. Type 1 has one step or one operation you need to solve, and so on. Type 3 and 4 have sometimes more than 3 or 4 steps, but they have things like combining like terms or the distributive property. The purpose of all types is to isolate the variable. That means get the letter by itself. Type 1 equations have one variable only once. They have one operation in them, and you solve them by doing the opposite operation as the one that's given. So these are the type of equations that we can solve. Notice that there is one variable in each one, and that there's only one operation: addition, subtraction. Here's multiplication and division. So let's go through and solve. For this one right here, n plus 2 equals 8. This means a number plus 2 equals 8. The opposite operation is how we're going to solve this. So it's n plus 2 right now. To get rid of the plus 2, to make the n all by itself, I need to take away 2. Whatever I do to one side, I have to do to the other side. So here's my opposite operation. Take away 2 here and take away 2 here. 2 take away 2 leaves just the n. And 8 take away 2 is 6. We're solved. N take away 5 is 30. So n take away 5 is, I'm just going to transfer that from the line above. The opposite of take away 5 is add 5. Line up my equal signs. I'm going to add 5 over here. So I'm adding 5 on this side, so I add 5 on that side. That's my opposite operations. Take away 5 plus 5 leaves just my n. 30 plus 5 is 35, and we're solved. A number divided by 5 is 100. So it's a number divided by 5. The opposite of that would be timesing by 5. So I have n divided by 5 times 5 equals 100 times 5. The 5's cancel out, one on the top, one on the bottom, leaves just my n. And on this side I have 500. So n is 500, and we're solved. The next one I have multiplication. 4 times a number is 20. So 4 times a number, line up my equal signs. The opposite of multiplying is dividing. So I'm going to divide by 4 on both sides. 4 on the top, 4 on the bottom, they cancel out. So n equals 20 divided by 4 is 5. So here's some more complicated ones. We've got integers, and sometimes integers here, and sometimes a negative variable. So let's try to work with these. So negative 2 plus n equals 8. So I have a negative 2 plus n. To get rid of a negative 2, I need to add 2, or go up 2. So I'm just going to add a 2 and add a 2, because adding 2 is the opposite of a negative 2. They cancel out, so now I have just n. And then 8 plus 2 is 10. Now I'm going to look back and see if that makes sense. If I have a negative 2 up here, and I go up 10, so I'm going to think of a number line. Here's negative 2. If I go up 10, 1, 2, I'm at 0. There's 8 more to go, which gives me positive 8. So that works, and it makes sense. 5 take away n is 30. So what I don't like is this negative n. That makes things really hard to solve. So what I would like to do is to put my negative n on that side. So I am going to do 5 take away n plus n, because I don't want that n on that side anymore, and do 30 plus n. So there's my equal, my opposite operation. Take away n plus n, they cancel out. So now I have 5 here and then 30 plus n on this side. So now it's just a single operation. I am going to take away 30 from this side to get the n all by itself. And then do 5 take away 30 on this side. So take away 30, there's my opposite operation. 5 take away 30 means 5 and then going down by 30 gives me a negative 25. And then 30 and take away 30 cancel out, so my n is equal to negative 25. I'm going to look back and see if that makes sense. 5 take away a negative 25. So if I'm taking away a negative, I add the opposite. That's an add the opposite. So it's 5 plus 25 makes 30, so that makes sense. Negative 4n equals 20. So this is a negative 4 times n. The opposite of timesing is dividing. I'm going to divide by negative 4 to get rid of the negative 4. Negative 4 cancel out, leaves just n. 20 divided by negative 4 is 5. A positive divided by a negative is negative because the signs are different. 5 over n equals 100. So 5 divided by n is 100. I don't like the n on the bottom, so I would like to move things around so that it's on top. 5 over n, I'm going to times it by n, and then times the other side by n. They cancel, so now I have 5 equals 100 n. Now it's just a simple multiplication, one-step equation. I'm going to get the 100 gone and get that 100 gone, or that 5, sorry. The hundreds cancel out, and 5 divided by 100, move the decimal place, n equals 0.05.